So the craftsman of yesteryear, as well as the craftsman of today, must, if you're using hand tools, you must be able to hold the wood. So the question becomes, what are the wood holding devices that are most practical? As I said in the PowerPoint, typically a craftsman needs 3 hands. But since he only has 2, he has to have something to hold the wood. And so we're going to talk a little bit about a few of the work holding devices. Below us you see a large European workbench. This workbench has what's known as a shoulder vise. This was typical of benches that came out of Scandinavia. I've added the drawers. The drawers are full of tools, and so they add mass. One of the key components of work holding is that you must be able to secure the device or the piece you're working on, but you don't want it moving around. So this particular bench full of tools weighs in excess of 1,500 pounds. So I do not move it around. But it does allow you to take the drawer cabinets out and reduce the weight if you ever needed to move it. Big bench uses square dog holes. I've made a lot of my own wooden dogs. There are also some commercial ones that we'll talk about in just a few minutes. But these work in conjunction with the twin screw tail vise. And the tail vise would be for putting boards long ways. We, of course, remove the lamp. But you can put boards long ways and plane them flat. The shoulder vise is for capturing a board, and you can pull out a drawer and it'll hold a board vertically for doing the shooting or the joining to make sure that the edge is 90 degrees with the flat. Very large bench. I like it a lot of mass. I made this bench back in 2005. The top is 4 inches of solid maple that are laminated pieces together, and then the base, of course, is some oak from a tree that I cut down and dried. The only metal parts on it are the twin screw vise on the end and this particular threaded Acme thread vise on the shoulder. Many of you may be interested in making handmade dovetails. This is known as a moxon vise, and a moxon vise is designed to secure your materials when you're cutting dovetails vertically. This would mount to the bench with clamps on either end, and then rather inexpensively use these dumbbells to provide a threaded means to increase or decrease based on the size of the material that you are seeking to add, cut your pins or tails. So this is known as a moxon vise. Not typically this wide. This is 24 inches in between centers, so you can make a large side for a piece of furniture or a toolbox or whatever you were doing. You can actually extend the holes out even further if I need to and add a larger chop on the front. This is just an add-on device. If you noticed last month's show and tell, Kevin May had added this to this vise. This is known as a mini bench vise, originally created or designed by Steve Latta. Steve Latta does a lot of work that's small and detail work, and he likes to get it up high. And so that's the purpose of this particular vise. It has an end vise on the end so that you can secure things. It has dog holes all down the center. You can use small, what's known as bench pups, or you can use a larger bench dog. Also on the side for work holding, it has these devices. These are known as Stanley bench hooks. They're Stanley number 203. I have 2 of those on the front. They can be adjusted in and out for holding a plank, a small plank, and shooting its end. This is secured to the big bench with F-type clamps, and then I have a vertical clamp here for securing a piece of wood horizontally but on edge to work on the edge of it. So very helpful, gets to work up here, and so if you're doing detail work, it gets to work to where you can see it. One other particular vise or wood holding component that I have here is what's known as a detail vise. This is bolted through one of the dog holes in the bench. It has a large Acme thread that you can purchase. This is from a plan that was included that's purchasable from Woodsmith. It has removable jaws, And it's great for working on small items that you may be carving or doing some type of inlay, and you need the precision to be able to capture that information, hold that piece of wood, and work with it up high as opposed to down on the surface of the bench. But if you ever think about it, this is a really cool vise to make, and it's very sturdy and it doesn't go anywhere. Another work holding device is this twin screw bench tail vise. One mechanism moves the vise parallel in and out. These are the machine dogs that you can purchase as opposed to the wooden ones that I've made. They have brass faces so they don't damage your planes. But this can move in and out, and it has the capacity to move out as far as the distance between any two dog holes. I have dog holes in the left, the right, and the center. We talked earlier about the large European workbench. This is a much smaller workbench. It still has a pretty significant amount of mass. It's what's known as a split top workbench, and you get the split top from the fact that these boxes are removable. You'll notice this box is mounted upside down, so you get a flat surface. It can be turned over as a tool tray as well. And this one I keep as a tool tray, and some of my most used items are located here. This vise has bench holes, bench dog holes. These are the Veritas bench pups that can go here. They are in line with the vise here for mounting small devices here. I have a relatively new planing stop that you mount longboard and you push against this planing stop. It has 4 different surfaces. And then of course I have a bench hook, and this is used for holding work pieces down to the bench. As I did previously, also included a drawer box unit here. When it's full of tools, it adds considerable mass, and this bench will not move around. For our next segment, we'll talk about some layout and measurement tools. In this particular case, we've got a lot of different options, and so we'll talk a little bit about those options and how they work in a hand tool workshop. We'll first begin with some of the marking products. Lots of different ways in which to mark your wood. 2 different marking knives, lumber crayons, Sharpie. Chalk comes in handy, especially for dark colored woods like walnut, and a China marker or wax crayon, helpful for marking out rough lumber in order to know where to cut it to shape. Beyond that, we'll move to measurement. You can see here lots of different measurement tools. 6-foot rule in wood, a 6-foot rule in metal, some antique 6-foot rules or 4-foot rules from the Stanley Company. These rules had brass fittings. They folded out and then they folded along a hinge to produce a 20, in this particular case, a 2-foot rule or 24-inch rule. Also, with regard to measurement, you've got a lot of different types of calipers, from the very sophisticated digital caliper that's battery operated to a wooden caliper from Stanley, a plastic caliper, some metal calipers, all of which are designed to measure both interior and exterior diameter, especially for round objects. Excuse me. Moving on beyond specifically marking out, we're looking at what's known as a marking gauge. In this particular case, single point on the lower side, double point on the opposite side. This would be for marking mortises. This would be simply for marking a line parallel to the fence. This particular one is controlled by the thumb screw here at the end in terms of distance between the 2 points. You would take your mortising chisel and lay it in between the 2 points and then mark off the wood. This is one in an exotic wood. This is one much earlier in time, made out of ebony with brass fittings. Also mortising on this, so this is a dedicated mortising gauge. Similar in appearance, but actually different in function, This is known as a cutting gauge, and a cutting gauge has an actual knife here as opposed to a point. The knife is designed for cutting across the grain. Two different cutting gauges, very similar in design. In both cases, a knife point that is designed for cutting across the grain. This particular one comes to a knife point. This one comes to a beveled point. Moving along, this is known as a scribe. This would be used for more for trim carpentry than for woodworking, but whenever you need to scribe along an uneven surface, such as brickwork or stonework, this would be used. As it relates to marking gauges, more modern design is the wheel gauge. This is also a sharp cutter. It can be removed and sharpened, but designed for cutting across the grain or with the grain parallel to this circular fence. A very simple product, but one that is quite useful when marking off two surfaces that are 90 degrees to each other. This particular hinge can be used for marking off a 90-degree angle across two surfaces of a piece of wood. This gauge is one I made. It's a Cocobolo centering gauge. These 2 points are designed for going on the side of a piece of wood. You turn it until both points contact. There's a pencil in the middle, and it creates a line straight down the center of a piece of wood. Another tool that I made quite some time ago, this is known as a beam compass. You see the two brass beams. This is a centering point both here, and you can install a point here as well and create a compass for very large circles. Speaking of compasses, this is a set of dividers that also includes connection for a pencil and can be used as a compass as well. And then here's just a straight set of dividers that can be used for marking the distance between 2 points. A product that comes in quite handy in the workshop is known as a tri-square. This particular square is a 12-inch version. It has a 45 and a 90, even has a scribe point for marking. Very handy in the workshop. It comes in both a 12-inch, a 6-inch version, and also an 18-inch version. You'll notice that this also has a center finder and a retracting head for measuring angles. Very useful in the workshop. The longer blade can come in handy, especially as you're working on larger projects. Speaking of heads, these are trammel points. These are marked along, used to mark points along a beam. Quite useful for large furniture, especially large furniture that involves some type of curve. These are antique Stanley trammel points. More modern points does the same thing, known as a beam compass head from Lee Valley or Veritas. Finally, a couple other items. These are all dovetail markers designed for marking specific angles for dovetails. This one is used for softwood. This one is for hardwood. A similar marker here for marking dovetails. And then what's known as a dovetail saddle comes in two different sizes. This is a 1:6 ratio, and this one is a 1:8 ratio. So all of these items are used for marking out projects, measuring projects, and setting yourself up for success before you start cutting.
We're going to talk about shaping and forming. These are the tools that will create very smooth surfaces that would be used in shaping and forming wood. I don't intend to cover a full range of products today because many of these products will be covered in more detail by Jim Milam in the July presentation. But what I would like to do today is cover things that are more unique, that are very set up for a very specific purpose. I'll start with some of the chisels that are representative of different classes, and then we'll move on to some of the plain products. First off, a long paring chisel. You want a chisel that has an extended blade, extremely flat on the back. You should be able to see yourself in the back, but used for paring very fine amounts of wood and making sure that the surface that it pairs is consistent and flat with the back of the bevel. Very handy chisel. This is known as a sash chisel. It's not quite as big as a mortising chisel, but it still has a pretty substantial blade. These were known for creation of window sashes, and so these are the specialty tools that would have been used for that purpose. You'll also note this leather washer here and then the metal bollard here on the end. These were known for striking. You wanted to pound these tools, and often cases you were trying to move large amounts of wood associated with the use of this sash chisel. Speaking of large amounts of wood, this is an 1 3/4 chisel. It's a Witherby chisel, typically used when you're trying to remove material, say in the creation of a dado or the sidewalls of a rabbet, where you want a very wide chisel. Often bigger chisels of this similar type were used in timber framing, but this would have been used inside a woodworker's shop. I mentioned mortising earlier. You can see from the thickness of the blade, this blade was designed to take a great deal of beating. This is an antique mortising chisel. It's used for creating the mortise that a tenon would go into, used with the slang name a pig sticker. It actually was used in the killing of hogs. So this is a very detailed, very thick blade designed to take a great deal of beating. Speaking of creating mortises, this is a crook neck chisel, and it's designed for reaching down in a mortise and cleaning out the material at the bottom of a mortise to make sure you've got a flat bottom mortise. Kind of a specialized tool. This is a Henry Taylor, but used for cleaning out material at the bottom of a mortise. This is known as a crook neck chisel, also a Henry Taylor, and it's designed where you can keep your hand above the height of the wood and yet still get in and pare material off. So used in special applications where you're trying to move material and you don't have room for your hand to be in the same plane as the edge of the chisel. Earlier we talked about Japanese saw as compared to Western saws. This is a Japanese chisel, and it's a dovetailing chisel. You'll notice this one is fairly thin. It's a 1/4 inch, but very high bevels on either sides. Gets really close into the corner of a dovetail. It has the rather significant ring or hoop here, and it's designed for taking a lot of beating with a mallet, but yet still producing very fine work. So that's a Japanese chisel. So for shaping and forming, we've talked about planes and chisels. Let's talk a little bit about a specialty type of plane. This is a scenario where you've got a plane iron held in a device that you either push or pull, either way. It typically involves a very small blade, and it involves a handle. So you can think of this much like a plane or a chisel. It's a cutting edge that's captured in a metal body, and it's designed for cutting very small work. It's designed for cutting shapes. It will work into the groove, and a lot of times when you're working in, the grain is moving this way, but when you're looking at the other side, the grain's running the other way. So you can turn it very quickly and run it in the opposite direction so that you're always planing with the grain. As you can see, there are a number of different types. These are all metal-bodied spoke shaves. They're all different types. This particular one is useful in that it has both a square face and a rounded face. So if you're working, say, a rung of a chair, you can work on the rounded face, or if you're doing a smooth surface, you can do a flat face. But very flexible tool. All of these are slightly different. They're all made for a slightly different application, but very useful, all designed for a specific shaping of wood. Also included in the shaping area are files and rasp, and so this is a selection of files and rasp. This is known as a cabinet maker's file. It's a very large. These are hand cut into the wood. It's very effective at moving wood, often used for a cabriolet or the shaping of some type of curved surface. That is indeed a modern tool. This is another modern tool that can be highly effective in shaping. If you can envision a bunch of hacksaw blades on edge, this is a smooth side, this is a rough side. It's a Japanese product made in Japan. It's called the Shinto, but it's a rasp that is designed for removing a lot of wood, especially on the coarse side, very quickly when you're shaping wood. The remainder of these are literally just files of different styles and types. Nicholson is a famous manufacturer of files. This particular file is a Nicholson number 30. It is a flat file designed for shaping wood. These can also be used with metal. You generally don't want to interchange between wood and metal, but they come in a number of different coarse. This particular one is a Nicholson number 49. This is also known as a cabinet maker's file, much coarser than the one that I just showed. They come in both flat and half round configurations, and then they also come in what's commonly known as a rat tail configuration, where the file actually is rounded and it has serrated edges on 360 degrees of the file. Very useful for working very small detail work. The keys to hand tool woodworking is to work with sharp tools. A craftsman has to have sharp tools, and so what we have here is several different means by which to make your tool sharp. The method that I use is diamond plates, and so I have varying different coarsenesses of diamond plates. The microcrystalline diamond is affixed to a steel plate, and so I just move from coarse to medium to fine. This is the ultra fine, and then this is a ceramic Shapton stone. So this is my my typical sharpening. Other methods that work quite well is putting emery cloth and gluing it down to a granite block. You want a granite block that has been tested and verified as being completely flat. Another method, of course, is water stones. This is a nice pond. You fill it with water, and the water stones are on a triangular block, and they can be turned, and so you've always got a water stone that's in the water. Another good method for holding blades and blades of planes and chisels. This is the Eclipse device. Both Lee Nielsen and Lee Valley have made more modern versions of this. This device still works very well for me. Final method that we'll talk about just briefly, which is a little bit counterintuitive, is a plug-in device for sharpening your hand tools. But the WorkSharp device works especially well for chisels. It has multiple different grits of round disc sandpaper, and then of course this is the leather honing. And when you turn it on, this creates a relatively slow RPM device for sharpening chisels and small blades. For our next segment today, we're going to talk a little bit about saws, and we're going to talk about hand saws. Hand saws from the perspective of doing a lot of different things for you and having a specialized saw that meets the particular needs of the craftsman and the project. We'll start with the smaller ones first. This is known as a gentleman's saw. And a gentleman's saw, in this particular case, is brass back. This would be used for cutting small dovetails, making boxes for very small projects. This is filed at approximately 20 teeth per inch. So a very small saw. This is an antique model. This is a much more modern model. This is a 10-inch gentleman's saw. It can be purchased today. It's a crown saw. Has brass back, 10-inch blade. Here again, primarily for cutting dovetails. As we move up a little bit larger, this is a very modern saw. This is the Veritas saw. Some people really don't like these because they vary significantly from traditional design. But this is a man-made material, very rigid for the back. Of course, that's the cover. This particular saw is filed at roughly 18 teeth per inch. But this is a modern back saw that is available today.
Similar in concept, but much more elegant in design. This is an English back saw, also probably big enough to be considered a tenon saw. This particular saw was made in Sheffield, England, probably dates from the 1870s. Large brass back, significant mass, also filed at roughly 18 teeth per inch. Used for cutting the shoulders on the tenons, cutting dovetails as well for larger case goods. If we move up to the largest back saw, this would have been, this is a 26-inch back saw, and it's got a steel backing on it. This would have been used in a miter box. And so a miter box is designed for cutting different angles, a lot of times for doing trim carpentry work, molding work. But this would have been a large back saw, most often used as a miter saw. This is a very rare saw. It's known as a bench saw, used primarily for cutting the shoulders of tenons. It has the nib like a much larger saw that's filed to probably about 12 teeth per inch. It has the curved handle, but it is not an enclosed handle. Not very common, a very highly specialized saw, but somewhat unique, but often, very seldom used out in the field, most often used by a craftsman at their bench. Let's skip this small saw. This is also a modern saw. This is a flush cutting saw, and you'll notice the blade has a great deal of flexibility. Designed for cutting very small, intricate items, many times used to cut the head off of a peg that you may have used as a dowel joint. In this particular case, this saw was made in Japan. Speaking of Japanese saws, we'll look at these two next. This is the large Gyocho. It has teeth filed on one side for rip and on the other side for cross-cutting. So the same saw can be used for cross-cutting and rip as we talked about earlier. Japanese saw always cuts on the pull stroke, not the push stroke. Western saws cut on the push stroke. Japanese saws cut on the pull stroke. The thinner material, because your blade is in tension when you're pulling it back, allows for you to cut a finer kerf, and some people believe it allows you to cut with less effort. This is a similar product, but it does have a quarterback to stiffen the blade a little bit. Also, probably used most often for cutting dovetails. And they're wrapped. This particular one is a more modern version. The more traditional ones would have been wrapped with a natural material. This is a synthetic material. Very seldom are these blades sharpenable. They're generally so hard that you cannot sharpen them, but they are easily replaced. You just loosen this screw, blade comes out, you replace it with a new one. Very seldom does anyone make an attempt to sharpen a Japanese saw. If we move into the larger hand saws, this would be typical of what's known as a crosscut saw. This particular one is a Richardson Brothers saw, made sometime between 1867 and 1895. The teeth, as we talked about earlier in the PowerPoint, are filed for crosscut. Typically somewhere on the order of 5 to 8 teeth per inch. This is a very pretty handle. This handle is apple wood. As we can look at you also notice this particular one has 5 bolted connections, the medallion, and 4 additional ones. This would have been a saw that would most likely have been used by someone who had less skill. The more bolts that you see in the saw handle gave it greater strength, but it probably meant they did rougher work. So you might have had this saw assigned to an apprentice or a younger journeyman that would have been doing framing or something that didn't require a lot of precision. In a similar manner, this is a rip saw, 26 inches, still has the nib, but this would have been designed for cutting with the grain. Also, in this particular case, it has four attachment mechanisms. Most likely would have been used by either an apprentice or someone doing rough work, not fine work. This would have been a carpentry-based type of saw. The purpose of the nib is subject of great discussion. No one knows for sure exactly what the purpose is. I subscribe to the philosophy that this was cut from a larger sheet of rolled steel, and this particular nib was where it was attached to the large steel. Other people believe that it was for starting the cut, so you would run it across a piece of wood, create a small chip, and that would be the beginning of your kerf associated with the cut. Other people think it's purely decorative. No one knows for sure, but it's a subject of great discussion amongst tool collectors. As you move down in size, you see this particular saw is also ripped. It also has the nib, but it's somewhat shorter. And as you move towards a shorter saw, you likely move up in terms of talent for the user. This saw is filed to a much greater number of teeth per inch, probably something on the order of 8 to 10 teeth per inch. It is also ripped. Would have probably been used by an experienced journeyman doing fine woodwork, or even the master. It does have 4 bolts to keep it a rigid connection between the handle and the saw, but because of the shorter size, would have been either in a journeyman's toolbox or a master's toolbox. Continuing with that same theme, even a shorter saw, you'll notice it only has the 3 bolts fixing the blade to that particular handle. Much shorter, would have easily fit in the master's toolbox, probably doing very fine work, which is consistent with what you would expect from the master. Would not have been used for framing. These saws have a much shorter stroke, and so you're not as productive, but yet you can have much greater control. This particular is the handhole is much smaller, but because you get greater control, you typically have that finger curled under there and your pointer finger pointed in the direction of cut, so you really only need 2 fingers in the handhole. This is a way to take a new saw. This is a saw that you can go buy on Amazon today, and I have taken the handle that comes as a very square block and shaped it much more like the traditional saws, and so created this decorative flourish, created some more decorative components there. Also used split nuts rather than traditional nuts to make this saw look much more traditional, but yet it is a Spear & Jackson saw. Spear & Jackson was headquartered in Sheffield, England. This particular saw is made in Japan, but it is a saw that is available for purchase today. And it's a very effective saw. Now, we talked earlier about Japanese saws not being able to be sharpened, but the Western style saws indeed can be sharpened. And you typically involve using files and cutting those files, cutting the saw plate. This is a traditional group of files that you would use for cutting different tooth patterns in a saw. These are available today. They can be purchased from Lee Valley. You obviously put handles on them. This would be for a large rip saw where you're doing 3 or 4 teeth per inch, all the way up to a very small back saw like we discussed earlier, where you may be doing anywhere from 15 to 20 teeth per inch. But this is a set of saw files. You can also use a device like this that I've just recently purchased. It's from Lee Valley, and it mounts on the saw blade and it uses a pattern to keep you filing at a particular angle across the tooth of the saw. The first step in filing a particular saw is to make sure all the teeth are at the same height. You will notice in some of these older saws that certain teeth are much taller than the others. The first step in filing a saw is to take this and run it across and make sure that you get all the teeth at exactly the same height. So this is known as a saw file. This one has been restored and I recently repainted it and added a new file. Once you get your teeth all filed, then you have to add what's known as a set. And this is a saw setting device. It has a little anvil, and you can adjust it based on the amount of set you want in your tooth, and then you put it on the tooth,
and you push the lever, and it sets the tooth. It literally bends the tooth over. And so you can use the adjustment knob to determine the amount of set. The larger the set, the wider the curve. And so it's going to be easier to push through, but you're going to create a lot more sawdust, you're going to create a lot more kerf. So your construction-oriented saws that would use for framing are going to have much more set. Also, typically, your crosscut saws are going to have more set than your rip saws. You'll notice this particular saw has very little set. The set is to clear the sawdust out of the gullet, the kerf that you're cutting, and remove the sawdust so that when you pull the saw back or you push it forward, it pushes the sawdust out of the kerf and allows you to cut much more easily and without the saw binding in the kerf. These saw sets come, this is a more recent one. This is Stanley number 42. They also made them in bronze and brass. So these are three different versions of a saw set. These are still available today for sharpening Western saws. Tonight we're here to talk about boring and drilling. We're going to talk about this from a historical perspective. Some of the oldest and earliest tools would have been craftsman made, probably made by a farmer for building facilities on his particular property. You can see that the handle here is just literally a stick with a hole in it. These are known as T-handled augers, and these would have been some of the earliest products. You can see over time that these particular tools improved. That's more of a shaped handle, and then as we got farther in time, we had a turned handle. These have been turned on the lathe. We got a little bit of a decorative bead there, and you also notice that they will allow for multiple different size bits to be installed in the T-handle. So as we move forward in time, there was a need for having a little more accurate, especially with smaller bits, so we would have moved to this type of brace, and this is one of the early types of braces. Most likely this came out of London. It was brass reinforced, and the bit would have gone here. In order to do more specialized drilling, we would have seen applications much like these. This is a post drill. Would have been mounted to a post in a barn type environment, and you would have generated all of your momentum by turning this crank, which turns that large flywheel, which then would have created drilling using one of these auger bits, very large auger bits. This particular one is 2 1/4 inches. If you needed to build a structure and you were into timber framing, which was the predominant construction method of that time, you would have had this type of application. This is known as a post drill, and it would have been for drilling mortises associated with building timber frames. If you were doing this today, you have the choice of either using a gas-powered item or continuing to use these type of beam drills. If you were looking and moving forward in time, the brace became quite the popular item, and this particular bit is a tapered reamer. But the braces were available in many different sizes. This particular one is a 10-inch. You also have a 12-inch. And the way they're measured is the distance from the center line to the handle. And the greater that distance, the more torque you can get on the bit. They increase to a 14-inch and then to a 16-inch. They also made an 8 and a 6-inch, which were known as chair makers braces. Didn't need a lot of torque, but they were much more precision oriented braces. You may ask yourself, what would these braces have been spinning? Here's 2 sets of Irwin style bits. The Irwin was one of the patent bits, and you can see it's based on flutes around a central post. You also may notice that there is a number here. That number in this particular case is number 10. That would have been 10/16, because a complete set is 16 bits. That would have been 1/16 graduated from 1/16 all the way up to a full inch. But they tell on each bit the number of 16ths that would have been involved. So this would have been a 5/8
bit. The other type of bit is a Jennings bit. This was the other patented bit that was available. You'll notice that these are all auger bits with a lead screw. And the lead screw has two different types of threads. This particular one is a fine thread. It would have been used for furniture making. If you were using this for construction purposes, it would have had a much coarser thread. But you'll notice here that the entire bit is fluted, not just flutes around a central shaft. So this was the other technique. This particular bit is also numbered. This one happens to be a 9/16, so just a little bit larger than a half. But this is another patented bit that would have been used in a brace. There are a lot of different style of braces. In order to get a lot of momentum, this is known as a breast drill. You put this against your chest and turn it, and especially if you're doing something horizontal, you can get a lot of accuracy drilling straight in and keeping this against your chest. If you're working vertically and bent over, you get your body weight pushing against that bit, so you gain that additional strength. This brace is also a 2-speed device. You can move this and slide it up and use a smaller set of teeth in which you get less speed but more torque. So a lot of thought went into the development of these tools. Beyond just the standard auger bits, there were a number of different types of bits. This particular type is a spoon bit. It was most often used by chair makers. The key to this is you can start it vertically and then tilt it horizontally. So if you think about the legs of a chair going into the seat, this allowed you to start the bit vertically and then tilt it and get a square hole. In order to make that connection even better, you often use this device, which is a tapered reamer. This particular device, once you have a standard hole, then you use the reamer to ream out a enlarged mortise, where the bottom of the mortise is much larger than the top. Earlier back in history, you would have had a center bit. This would have been some of the earliest, might have been in the early brace or even used in the wooden brace. It has a center post with a cutter and a scorer on the outside. These would have been used probably in the early to mid 1800s. Looking specifically at the tapered reamer, that would have been to make a tapered mortise. And one final type of bit, this is just a twist bit, but you can see from the size and type that this predates the modern twist bit that is available. Also numbered with a 6, so this would have been 6/16 or 3/8 size bit. You may ask yourself, where would you use these bits in today's woodworking? Lots of different opportunities. If you're working without the availability of power, obviously these make sense. If you need very tight control, these are known as egg beater drills, and they were made up through the 70s, and this particular one is almost in mint condition. The bits for this are stored in the handle. You'll notice they're fairly small bits. Typically you would not use one of these for any bit larger than 1/4 inch, but it gives you great control, often used for mounting hinges as you make doors or any other device that needs to be hinged. It gives you great control. These also came in multiple sizes. As you got to larger, you could do up to a 1/2 inch bit here. You've got a handle to hold on one side, and you can generate a fair amount of torque with this larger handle, and it would have been used in an environment just prior to using a brace and bit. Multiple different kinds of braces and bits. Predating the more standard is what's known as a Spotford brace. This is an all-metal brace. It had a thumb screw here. You inserted the bit, tightened up the thumb screw. These came in multiple sizes. Some of them had wood handles, some of them metal. And then as you worked down in size, this is a jeweler's brace. And so you would have had the opportunity to have a very small and great control associated with this particular brace. If you needed to drill and you were a long ways away in terms of where you could put the brace from where you wanted to drill the bit, or where you wanted the bit to drill the hole, You've got brace extensions. That's a shorter one. This is a longer one. So you would have mounted your bit in here, mounted that in the brace, and you could have drilled a long distance from the hole location. Speaking of tough hole locations, this is a corner brace. And so this was invented and used primarily by the telephone company when they were installing telephone lines inside of houses. You could put this right in the corner, and then it allowed you to turn the brace using a gear mechanism here to transfer the motion, but it would allow you to put the hole right in the corner, right up against the baseboard when they were installing new phone lines in houses. So those are some of the items that we were covered today with regard to drilling and boring. Next segment of our program tonight, we'll talk about striking tools, and in some cases these will be striking with a blade, and in some cases it's just the tool itself. The focus here is to look at the variety of the tools that are used for that application, and then discuss the specialty nature of these products. We'll start with one of the smallest tools. This is a 2-ounce brass hammer. It is used for adjusting the iron in a molding plane, and we'll talk about molding planes when we get to the shaping and forming, but very small, but very delicate use, but very customized just for that application. If you need a slightly bigger one, this is a 3-ounce bronze hammer, also used for adjusting the irons in molding planes. Also a very small hammer, but a ball peen hammer, a very small ball peen hammer, probably made in about the 60s, also 2 ounces. Not sure of its practical application, but I thought it was neat. Looking at some other rather specialty hammers, this particular one has a plastic head. Not 100% sure what it's used for, other than typically it's considered non-marring. So if you're hitting wood with this, you don't leave a mar on the wood. But not a lot of practical applications. We'll go through these fairly quickly. This is a tack hammer for most likely the upholstery trade. You can hold tacks and pull tacks with the claw, and then drive tacks in with the point. This is a planishing hammer. This would have been involved in the jewelry trade for forming metal. You've got the bulbous head here, and then the flat face there, with a rather distinctive handle. Larger versions of this are used in the auto body industry. This hammer is actually available today. It is from Lee Valley. It has wood faces that are replaceable with a bronze head. I understand that it is called a mortising hammer, but it's used for driving large mortising chisels for hand mortise. Small blacksmithing hammer used to form edges on small goods and then chip away for the splatter and make a much nicer joint. Shingling hatchet. This would have been used for putting cedar shakes on the roof and sides of houses. As you might suspect, this particular hammer's got a waffle face for driving the nail, and then this is for trimming the actual shingle on the roof or at the job site, not for initially making it, but for trimming it as a part of the installation. Bronze hammer here. This particular one is a number 4. This is a 6-ounce hammer used for driving chisels when carving. Typically known as a carving hammer, but for tapping chisels, not really driving them in the shape of a mortise, but more for carving work. This is a Warrington pattern hammer. Warrington was the manufacturer. These came out of London. This is for starting very small tacks and not hitting your fingers. And then of course the standard face. This is a 10-ounce version. They came from anywhere from 2 ounces to 2 pounds. Look specifically now at older hammers. Give you some idea, this particular forging was a relatively flat claw for pulling nails. This one is a relatively strong curve for pulling nails, but these are much older hammers, would have dated sometime back into the early 19th century. This hammer is a cobbler's hammer, would have been used for making shoes, probably also dated to the late 18th, early 19th century. Moving beyond just those things that are metal, I'm looking specifically at mallets. I have a number of mallets. This, of course, is a commercial mallet that you can purchase today. This is one that I made, very similar. The head is made from essentially a shrub called mountain laurel. It's a very lightweight wood, but an extremely dense wood, and you can pound on concrete with that wood and the concrete will break first. Larger version, also mountain laurel for the head, walnut for the handle, specially shaped to fit my hand, but this is Mr. Encouragement. It will encourage a joint to close relatively quickly. Looking specifically at carving mallets, this is the one I use regularly for carving. It is lignum vitae. I've used that for over 20 years, and you can see that it only has a relatively small indentation from driving carving tools. Also lignum vitae, both the sapwood and the hardwood, very dense, heavy mallet. And then this particular mallet is a copy of one that's on the cover of a tool magazine, but this particular mallet is turned in dogwood. Dogwood is an extremely hard wood and useful for carving mallets. This would have been used for very gentle tapping of a carving tool, trying to carve very fine work. These tools, of course, you recognize very quickly. These are hatchets. This is actually known as a bench axe, primarily used for green woodworking. Both of these were made in Sweden, a significant tradition of green woodworking in the country of Sweden. That's about the only source for these types of tools today. And for hewing, you have the option of using either an adze with a flat blade. This would have been done to hew a log with swinging in between your legs, trying to make flat sides on a round log. Another way to do the sides of a round log is with that right or left hand hatchet or small broad axe. You can buy a left hand or right hand broad axe. Also made in Sweden. If you have a smaller application and you're carving bowls or even carving small water vessels like a canoe, this hand adze. You've got a face for driving a nail, and then you've got a sharp blade on the backside for cutting out. In many cases, the blade is at a much greater radius than this relatively flat one. The greater radius ones would have been used for hulling out bowls and small treenware. Some of the final things we're going to talk about today, this is known as a froe. And so a froe is used for splitting out green wood. It's also known as riven wood. You would take a round log, take the froe, lay it on it, and drive it with this mallet. This mallet is also dogwood, what was traditionally used to drive mallets because it takes a great deal of impact and it very seldom ever splits. So froe and a mallet. And then of course a tool that probably everyone is familiar with. In order to get smaller billets of which to work the froe, you would typically use a wedge and a very modern, obviously, maul with a plastic handle. But some more striking tools that would involve some of the early stages of woodworking in creating much smaller pieces from which to work.